simplifying, multiplying, dividing. I wanted to go over 22 and 20, and I'm going to start with 22 first, and then we'll talk about 20. 20 was the special one of the group. So we'll save that one. Do number 22 first. So Friday we talked about simplifying expressions by factoring. So essentially something needs to be identical for it to cancel. You can't just cancel parts of a problem. So I cannot cancel the xt and the xt because they happen to both be xt's. I can't just wipe them out if things are being added or subtracted. It must be in multiplication form, and the term must be identical, the entire term, or the entire group of terms. So instead, number 22, there she is. How would you start, do something with 22, Brendan?
Factor by grouping.
Factor by grouping. So what does that mean, Brendan? How would we factor by grouping?
You take the first two terms, you take out what they have in common, and then the second two terms, you take out what they have in common.
Yeah, so we're going to do that for the 4 pieces of the fractions that are up here. So Brandon, the first 2 terms have what in common?
They have an S,
And that would leave you with?
X minus Y.
X minus Y. And then the second 2 terms?
T, and then that would be X minus Y, and then you can combine those into just write S plus T times X minus Y.
Right. Alright, so grouping, your parentheses must be the same in order for you to combine the terms that you took out, the GCF that you took out of each pair. So whatever's in parentheses has to be the same so that you can group then the first term in front together and then the parentheses together. So doing that same process for each of the numerator denominators. Looking at the second one, we have the x that they have in common, so take that out, you get s plus t. And then we have a y in common, take it out, you get x plus t. So x plus y, and then s plus t. So now my first fraction, numerator denominator, is factored using grouping. You're going to do that same process within the second one. So we would take out an s. What do you take out for the other 2 terms, Brandon?
A negative T.
Yeah, a negative t. So if that next term after my little bar there is negative, you need to take out a negative. And when we pull out that negative, we end up getting a positive x plus y. So now we have s minus t and x plus y. And then finally, on the bottom, we have an s in common. Again, it's a negative t, so that second pair of terms there, we have to take out the negative. And when you do that, you get x minus y. So s minus t and x minus y. A lot of little factoring there. Chelsea, what happens?
It equals 1.
It equals 1. So the s minus t cancels. The s plus t cancels. And then diagonally, you have the x minus y, the x plus y. So 2 of the pieces cancel within that fraction, and then the diagonals cancel out. You just get 1. Why isn't it 0?
Because it would be 1.
Yeah, it's being multiplied. It's not being added or subtracted. So it's not like I have 2x minus 2x, because that equals 0. 2x divided by 2x is 1. So, looking at number 20, I'm going to ignore the first numerator, because you should be able to factor the rest. Maybe somebody was able to get that first one to factor. This is a pretty good factoring problem here. So again, ignore the first numerator. Kate, how would we factor the first denominator?
Factor to 5.
Yeah. So x minus y plus 3. How about the middle numerator, Kate?
Factor to 15.
15. Are you okay?
Yeah. Yeah.
You need a drink?
Yeah.
Yeah, maybe?
I don't know. I just like swallowed spit.
And you started choking on it. Why not? That's tricky. You gotta be careful there, Libby.
One way to get out of that.
Kate, what do you factor out of the bottom?
The 9.
The 9. So pull out a 9. And then can it factor further?
Yeah.
How?
I'll factor down to x plus y times x minus y.
Right. So that is the difference of two square patterns. So we've talked about a lot of different patterns this year. We use the Subt formula for a sum or difference of a binomial. So that's the perfect square pattern for a, Subt goes with a sum or difference of a cube, not triangle, cube. These are perfect squares, so this is the sum or difference of a perfect square. The Subt formula goes with the sum or difference of perfect cubes. And then we also talked about the trinomials when it's 3 terms, which we'll see up here in a minute that they also can factor. So we've got almost all of it factored. This one is just a 1. Yeah, right?
Yeah.
And Kate, that last fraction, we could pull out a 2. And then that gives us 3 plus x plus y. It's a lot of GCF there, except for the perfect square, difference of perfect square. So if you look at that first one, since there are 4 terms is usually a good gauge as to you're going to have to factor by grouping somewhat. However, factor by grouping can be done multiple ways. And number 22 is one way to use factor by grouping, but it's not the only way. So this is a specific type of factor by grouping where pretty much you put a line down the middle and you take out a GCF. But factor by grouping doesn't always have to be done by placing a line down the middle and taking out a GCF. Sometimes factor by grouping is done by looking to see, do the terms have something in common that you're looking at besides just a GCF. So they might have something else in common. They might not have a GCF. But if I put a line down the middle here, and I take a GCF out, I pull an x out, but then there is no GCF with 9 and negative y squared. Brandon,
They're both perfect squares.
what do you mean they're both perfect squares?
So you can take 9 minus y squared and split it up into 3 plus y into 3 minus y.
You could, yes, but then you still have that x squared plus 6x. And it needs to be placed into multiplication in order to get it to factor. Cade.
You could split it towards x squared plus 6x plus 9, because that can factor.
Yeah, so if we group 3 terms together, that trinomial is also a perfect square. How does that factor, Kate?
Plus 3 plus 3.
Yeah, so this factors as x plus 3 times x plus 3, or we would say that it factors as x plus 3 squared. So that is a perfect square trinomial. 3 terms. It's still a perfect square because 9 is 3 times 3. 3 times 3 adds to be 6. So then if you look at what you have, so we're grouping because we group 3 terms together, but now we're done with the grouping process and you have to see is there a pattern left in the pieces that you have. Kate, is there a pattern left in the parts that we have left?
It's the squares, and do x plus 3 plus y times x plus 3 minus y.
So the parts that remain are still squares. It's a subtraction, so it's still in the form of a squared minus b squared. We did this problem when we used SOAP, except they were cubes instead of squares. Jenna, I actually think you might have done one of the ones that did it. It was a long time ago. That was way back in chapter 7, but I feel like you may have done that problem for the class, but it was cubes instead of squares. So a squared just becomes a. So if it's x plus 3 squared, my a term is just x plus 3. And then the plus sign, and with it then you take the square root of the y squared. So now it's x plus 3 plus y. And then that same piece, I didn't give myself enough room. I would do the difference part. This stays the same. It's still x plus 3 because that's my a term. But now I'm subtracting the b term, which is the minus y. So that's using the difference of, it's using grouping. But then after you're grouping, you're using the difference of 2 squares, or the perfect squares formula, whichever you want to refer to it as. So now it's factored because everything is being multiplied. Whereas if you just did something else, you're still going to have an addition sign somewhere. And if there's an addition, you can't cancel until everything is in parentheses being multiplied next to each other. We can cancel now because we have an x, a minus y, and a plus 3. They're not written identically the same way, but all the terms are the same. So those would cancel. Here's an x plus 3 plus y. Here's an x plus y plus 3, so that's the same. We have the x minus y in the same fraction. Anything else, Kate? The numbers. Yeah, they can simplify as well. So 15 goes into 5, or 5 goes into 15 3 times. And then you can use that same number 3 and reduce it with the 9, because it can still be broken down. So numbers, when you're reducing them, if you still have something left there and it can be reduced a second time, then we can do that. So the 9 becomes a 3. What's left on the top? A 1. And then on the bottom, we have the 3 and the 2, and then the x plus y. Questions? There are other questions? I think those are the hardest ones. So we're going to do 4 problems again. I think it was 4 problems every day except for the page that had the exponents of them. And this is it. So we'll start reviewing on Wednesday. We're not going to do the solving equations or the complex fractions, which we didn't get to, that are also in that packet. I know, apparently, not a good place to be. You know, this morning, 4th period, I was walking back there to help a student that was sitting right behind you, and I have a skid mark there because I tripped over my own 2 feet and skidded across.
Oh, yeah.
So I almost fell into her. But thankfully I caught myself before falling into her.
I don't even know how I started.
Well, and I was just walking there were no backpacks in the way. I just
Yeah.
I had heels on then, so that would be my excuse. I was done with the heels.
It's cursed back here.
It might be.
Yeah.
Stick with the flip flops. Heels are bad.
My bathroom keeps trying to kill my mom.
I hate when that
She
happens.
split her head, she split her forehead open, and she ripped her Achilles tendon all in the same bathroom.
Wow, that's dangerous bathrooms. I would put big caution tape and don't go in that one anymore. Alright, so adding and subtracting fractions. We've done this in chapter 1 with composite functions, domain and range. Chapter 2, we graphed them. Chapter 7, we did the partial fractions. We just did this stuff with limits. So we've done a whole bunch with fractions. Chelsea, what do you need to do to get these fractions combined together?
Find the least common denominator.
Yeah, find the least common denominator. And what would you do with the least common denominators here?
It would be x plus 2 times x minus 2.
Right, so if there's a term that needs factored or a quantity that needs factored, make sure you factor it first. And then the least common denominator are any different factors that are in your denominators. So if I had 3 different factors, then I would have a denominator, a least common denominator that had all 3 factors combined together, but just listed as parentheses. You don't need to multiply them together. Chelsea, the one on the left needs
The x minus 2.
right. After you decide what your least common denominator is, then you apply the missing piece to any of the denominators that are listed there. So the one on the left has the x plus 2. It's missing the x minus 2. Apply it to the bottom, apply it to the top, and then if you need to multiply the numerator by that least common denominator piece, then you want to do that. So we have x squared minus 2x. That's my first fraction with the x distributed. The second fraction didn't need anything because it had the common denominator, so it's just a minus 2. So x squared minus 2x minus 2. Can that be factored? No. But check to make sure it can't be. So if you can factor it, factor it. Factored form is simplified form. Factoring usually helps continue to reduce a problem. Because one of those factors on the top might be the same with the bottom. Questions? Alright, looking at the second one. Number 2, we have 5u over 6u minus 15. We're adding that with 30 minus 7u over 15 minus 6u. Michael, what do you notice about those denominators?
They're opposites of each other.
Yeah, they're opposites of each other. How could you make them the same?
You could multiply either one by -1.
Yeah, you can multiply either of them by a -1, or you could factor out a -1, depending on what you think, how your brain is thinking. So Michael, which one are you going to multiply?
Just multiply the left by
Okay, so if you multiply the left by a -1, whatever you do to the bottom, you have to make sure you do to the top. So if I'm multiplying by a -1, both parts need to be multiplied by a -1. As long as you're keeping the fraction equivalent, you can multiply it by anything that you want. So the top would be -5u, and the bottom turns into a -6u and a +15. And that's just multiplying the whole bottom by a -1 and the top by a -1. Brandon.
Whenever they combine, you get 30 minus 12u on the top, divided by 15 minus 6u, which is equal to
And then Brandon, what could you take out of the top? 2. So 15 minus 6u, that's supposed to be a 1. So after you combine those numerators together, Brandon said you could take out a 2. Taking out the 2 enables us to cancel those quantities because the whole bottom is the same as what's in the parentheses on the top. And you just get 2. So that's not necessarily like finding a least common denominator by multiplying by pieces, but instead noticing that they're almost the same, they're just exact opposites. And either factoring out a -1 or multiplying both numerator and denominator by a -1. Questions? So number 3 has 3 fractions in it. We have 1 over x minus 1 over x, or 1 over 1 minus x. And then you're adding 1 over x minus 1. Brandon, what do you think?
Since the two 1 minus x and the x minus 1 are exact opposites, I just changed the subtraction sign to addition and I made it -1 plus x.
Yeah, so again, using that negative fact, so he said he changed this to addition because if I multiply both pieces by a -1, so using that negative fact, we have 1 over x. This becomes, on the bottom, x minus 1, because you're distributing the negative through. And there's a negative in between the fractions, but now I have a -1 on top of the fraction. So that would turn it into a plus sign. So the negative and the -1 turn into a positive 1. So if you have exact opposites, depending how you want to think about it, multiply both parts, numerator and denominator by a -1, or you can think of it as factoring out a -1 from the denominator. What else can you do? Chelsea?
Combine the x minus 1 fractions.
Yeah, we could combine these together because they have the same denominator. How would you add them together, Chelsea?
It would be 2 over x minus 1.
Right. So if the denominator is the same, you keep the denominator and just add the numerator together. So 1 plus 1 makes 2 over x minus 1. So if the fractions have the same denominator, add the numerator. And then Chelsea, what would your common denominator be?
X times x minus 1.
Right, so this one has an x. It's a different piece or a different factor compared to the x minus 1. So an x by itself is different than the x minus 1. Then multiply whatever your current denominator needs to get to the least common denominator. So the first one needs x minus 1, and the second one needs the x. So my first fraction has a 1 times x minus 1. The second fraction has a 2x. So we would get 3x minus 1. Can anything be canceled or reduced? No. If there were parentheses here, then yes. But the 3 is attached to only the x. There are no parentheses. So it just stays as 3x combined together and then the minus 1. So don't over cancel things that can't be canceled. 3x attached with a minus 1 is different than an x minus 1 ways. So the last problem down there looks like a big one. Lots of exponents, lots of powers, bigger numbers. Leave the first fraction be. It's just a 3 with a 25h on the bottom. That can't really be broken down, changed, nothing can happen with that one. Kayla, have any ideas for the middle denominator?
You could pull out a 5h
Sure. If you pull that out, what do you have left inside?
h minus 5.
H minus 5. Before you move on to the next fraction, just take a peek at that fraction. Is there anything you could do just with that fraction, Chelsea?
Reduce it.
Yeah, you could reduce it. So fractions can be reduced because you can still reduce the top and the bottom. Even though the other things are being added or subtracted, if something reduces within its own fraction, do that. It makes your numbers smaller. What does it become, Chelsea?
Just 4 over h minus 5.
Yeah, so the h's cancel, the 20 becomes a 4, and then the 5 goes away as well. So 4, and then h minus 5. So before you go like crazy getting a common denominator, just like look to see. You've got huge numbers. I mean, they're larger than the other ones we worked with. See if something else cancels. All right, my third fraction. Eris, how could we factor that denominator?
4 h minus 5.
Okay, 4h minus 5. And then on the bottom?
And then it's h plus 5.
You're close.
No, h minus 5 of h.
So h minus 5 and h minus 5. You could also write them together in one fraction, or one quantity if you wanted to. You could say h minus 5 squared. So 25 is 5 and 5. If they're both negative, then I get that negative 10. So Eris, what would happen with that fraction?
You can cancel out to the h minus 5.
Yeah, so they cancel. So we have 3 25h minus 4 over h minus 5 plus 4 over h minus 5. What happens? 8.
You can add the 4 over h minus 5s, and then you would leave them just the 3 over 25h.
Yeah. So like the problem above, they were both adding, so we combine them together. This problem, they're opposites. We have a negative and a positive. They're identical. They cancel. And you're just left with 3 over 25h. Did you need to use common denominators at all? No. I was just simplifying. So sometimes fractions simplify and the common denominator part isn't even necessary. Questions? We're done taking notes for the rest of the year. So sad. So I have your take-home quiz, which you have 13 minutes